lovely viewers, welcome again to Mathematics and I. It is your favorite presenter, Jeff Nino, and today I'll be teaching you how to solve the problem which you see on the board. And the question is actually a trigonometry question, okay? And it says, prove that the square root of 1 plus sine A over 1 minus sine A is equal to sec A plus sine A. Now, this sometimes might be a technical question to some students, but how do you really solve this problem? First of all, let us take a look at the right-hand side of the equation, which is actually sec A plus tan A. You will notice that they both have something in common, and what do they have in common? They both have cos in common, cos A. And how is it possible? Let me show you. Now, sec A simply means 1 over cos A, which is the inverse of cos. And tan A, on the other hand, means sine A over cos A. So you would see that they have cos A in common. So now that we know this, what do? Let us come back to the left-hand side of the equation, and we are going to divide all through by cos A. Okay, let's begin. All right. Now, bring it down the question, which says the square root of 1 plus sine A over 1 minus sine A. This is the original question. So now let's divide all through by cos A. A bigger square root. So I have 1 over cos A plus sine A over cos A all over the denominator now. Again, 1 over cos A minus sine A also over cos A. Right, now let's proceed. We're going to be having this square root of, now 1 over cos A is sec A, which is the inverse of cos. So we have sec A plus, now sine over cos is tan, so we're going to be having tan A plus tan A all over, also the denominator is the same, but with the sign differs. So 1 over cos A also gives us sec A. Now we have a negative sign. Now sine over cos gives us also tan A. Alright, so now that we've gotten to this stage, what do? We are going to rationalize. And while we're rationalizing, we are rationalizing because we want to eliminate the root sign as the denominator. Now some of you might be wondering, where actually is the root sign as the denominator? You know that this root sign which you have here affects both the numerator and also the denominator. And it is not so correct to have a root sign as the denominator. So now how do we rationalize? We use the denominator, which is sec A minus tan A, to multiply the numerator and the denominator. But the sign changes. If here is a negative sign, it becomes positive when they are multiplying. And if there is a positive sign, it becomes negative when multiplying. Let's do that. So when we are multiplying, we're going to be having this root sec A plus tan A over sec A minus tan A. Now let's multiply now. Multiply by another square root. Alright? Now, don't forget we are not using the numerator to multiply. We are using the denominator to multiply. So what did I say? Minus changes to positive sign. So here becomes sec A. Now minus becomes plus tan A. Again over sec A plus tan A. Alright. So this is how you get about it. Now let us multiply. You will notice that in numerator here, we have sec A plus tan A. Also at the numerator here, we have sec A plus tan A. So it means we have sec A plus tan A in two places. Now representing this in index form, it means we simply have sec A plus tan A raised to the power of 2. Because this is a function of power 2. It shows that sec A plus tan A occurs 2 times. Now, at the denominator, we have. Now, sec A minus tan A multiplying sec A plus tan A is simply like you are working with difference of 2 squared, which says if x plus y multiplies x minus y, it simply means x squared minus y squared. That is it, difference of 2 squared. it becomes, now you should know that sec square A minus tan square A is equal to 1. Now some of you might say, how is it 1? How is sec square A minus tan square A equal to 1? Now I'm going to show you. Now from the general formula which says sin square A plus cos square A is equal to 1. This is what we are going to do. We are going to divide all through by cos. Alright. Now if we do that, we're going to get this. Here becomes over cos square A. Here becomes over cos square A. Here also becomes over cos square A. Let's go. Now don't forget we said sin over cos is tan. But because of the square is carried, it means sin square A over cos square A gives us tan square A. So here becomes tan square A, right? Plus, now cos square A cancels out cos square A have 1. Equal to 1 over cos A sec. So here becomes sec square A. Now, if we want to make 1 subject of the formula here, tan square A goes to the right hand side of the equation. Now when tan square A crosses the equality sign, it becomes minus tan square A. So here remains 1 is equal to sec square A minus tan square A, which is exactly what I said here, that sec square A minus tan square A is equal to 1. So it simply means that what we have now at the denominator is 1. So writing this, we're going to have in this the square root of sec A plus tan A all raised to the power of 2 over 1. It's as simple as that. Now don't forget I said that the root sign affects both the numerator and also the denominator. Of course, if we should separate it to make things clearer and easier to understand, this is what we are going to get. If I should separate it, I'm going to get something like this. Here becomes the numerator square root of sec A plus tan A raised to power 2 all over the square root of 1. That's what you get if you should separate it. Because the square root affects the numerator and the denominator. Plus, when square roots cancel out the square, we are going to be left with just sec A plus tan A. And now the square root of 1 gives us 1. And of course, sec A plus tan A divided by 1 gives us sec A plus tan A. And this brings us to the end of the question, which says, prove that the square root of 1 plus sin A over 1 minus sin A is actually equal to the square. So what? Sec A plus. So this is how you solve the problem like this. When you see in any condition, classroom and wherever. So class, we have come to the end of today's teaching and I hope you've learned something new. If this is your first time joining us, please don't forget to subscribe and also put on your notification bell so you get notified each time we give our videos. Also help us to share the video so it goes far and so people can also learn from it. So we'll meet again in our next video. Thank you for joining me, thank you for listening to me, and thank you for watching. Bye for now.